Hello and welcome to our class. We continue with differentiation, our second lesson. Before we start, please do subscribe to our channel and click the notification bell to always be updated whenever we upload new lessons. Share our handle at Nakati244 and even these lessons. Now we start differentiation. Now we said differentiation is simply getting the gradient function of a curve. So we do a recap and we say that differentiation is getting the gradient function of a curve from our previous lesson. When you get the gradient function, then you have differentiated. Now when a function is in this form, y is equals to ax raised to n, then we said when you differentiate y with respect to x, that is dy dx, you take this n, you multiply by a, that is an x, then you subtract 1 from this power, n minus 1, and that is how you differentiate. Now you're supposed to also know something, that always make sure the function is linear before you differentiate. Now in our syllabus we don't use other formulas like chain rule and the others, so make your functions linear. For example, if I have y is equals to x into x minus 1 over x plus 1, and I'm told to differentiate this one, what I do, I first of all simplify this function so that now it is easier and it is in linear form, so that I can easily differentiate. So if I'm to differentiate this one, I will start by factorizing the numerator. So if you check this one clearly, this is a difference of two squares, which is a squared minus b squared. We always factorize it as a plus b and a minus b. So if you check, this is the same as x squared minus 1 squared. This one can be factorized as x plus 1 and x minus 1. So therefore you're going to have numerator y is equals to x into x plus 1 and x minus 1 divided by x plus 1. So if you do this one, you can now simply check the common factors in the numerator and denominator. So here we have x and this one, so you're going to remain with y is equals to x into x minus 1. So simplified, this one will give you x squared minus x. So you multiply x with everything inside that bracket. Now when it is this in this form, now it is very easy for you to differentiate. So we just say now therefore our dy dx will be, this is 2x, 2 multiplied by 1, it is 2, then you minus 1 will give you 2x, then minus, this is the same as x raised to power 1, so this will be 1 times whatever is in front here, which is 1. Then if you minus 1 from that power, you're going to remain with 0, so it will be x raised to 0, that is 1. 1 times this 1 is 1. So, and this is your gradient function. Another one, example, we have y is equals to x squared plus 4x plus 4 all over x plus 2. So what we do, we simplify this one first before we differentiate. So look at the numerator is a gradient function, so we can find the product and sum. Now product, you take the coefficient of a, x squared, and then you multiply by c. So product is always ac. Now this one will be 1 times 4, which is 4. Then b, sum is always the b, the coefficient of x, which is the b, so it is 4. Then we look for two numbers that when you multiply them you get 4, and when you add them you get 4. Those two numbers will be 2 and 2. When you get the two numbers, what you do, you replace now this 4x with these two values, but now you just add x here and x here. So you're going to have numerator as x squared plus 2x plus 2x plus 4. So you factorize these two, you get what is common between x squared plus 2x, so that will be x into x plus 2. Then here you check what is common, it is plus 2. You factor it out, so we're going to have x plus 2. So you put this and this under one bracket, so we're going to have x plus 2 and x plus 2. So that is our numerator. Then now you're going to have, if you combine with the denominator, y is equals to x plus 2 divided by x plus 2. So you're going to notice that you can cancel one factor in the numerator with the denominator. So we're going to remain with y is equals to x plus 2. Now from there is when now you can simply differentiate. So we're going to say our dy dx will be, so this is like x raised to power 1, so 1 multiplied by whatever is in front here, which is 1. Then you minus 1 from that power, you remain with 0. So x raised to 0 is 1. So 1 times 1 is 1. Then we said if you differentiate a constant, it is 0. And that is how we differentiate. Let us look at the last one. See, I am given y is equals to x raised to 4 minus 2x 3 plus 3x raised to 2 plus 2x minus 5 divided by x raised to 3. So again, you can't differentiate when it is in that form. First of all, make it linear. So divide everything in the divide everything above there. So that is solution. So we're going to have y is equals to x 4 divided by x raised to 3 minus 2x cubed divided by x raised to 3 plus 3x squared divided by x raised to 3 plus 2x divided by x raised to 3 minus 5x raised to 3. Then try and simplify this one. So we're going to have y is equals to, so according to laws of indices, if these are the bases and these are the powers, so to get what is the answer here, you just minus the powers. 4 minus 3, you get it is 1. So this is going to power 1 minus 2. So this one it is x raised to 3 and this one is x raised to 3. So 3 minus 3 is 0. So you have x raised to 0 here. Then plus, here we're going to have 3. Then this one is now 2 minus 3. You get it is x raised to minus 1. Then the next one, we're going to have 2x. So this is like x raised to power 1. So it will be 1 minus 3. You get it is minus 2. Then finally we're going to have minus. So this one here, when there is no value of x, it means it was x raised to 0. So you can put it there so that you can use it to solve. So it is now 0 minus 3. So that one will get it is 5x raised to minus 3. And that is how you simplify it. So if I write it now in a proper way, you're going to have y is equals to x, that is our first one, then minus 2, because this is now x raised to 0, this is 1. Then here we're going to have plus 3x negative 1 plus this will be 2x negative 2 minus 5x negative 3. Now, if it is now in that format, it is easy for you to now differentiate when it is done in that way. So it is linear. Now it's easy for you to differentiate. So now you can just come and say our dy dx will be equals to, you differentiate in parts as we join them together. You differentiate this one, you add to this one as you move on. So if I differentiate this one, this is like x raised to 1 again. So 1 multiplied by 1 is 1. If you minus 1 from this power, you remain with 0. So x raised to 0 is 1. So when you differentiate this one, it is 1. This is a constant. When you differentiate a constant, it is 0. So we are done with that one. You come to this one. Negative 1 times 3 will give you negative 3. Then x raised to negative 1. If you minus 1 from this power, like that one, it's going to be negative 1 minus 1, that will be minus 2. Go to the next one, negative 2 times 2, you're going to get negative 4x. Then this one you minus 1 again, so it will be negative 2 minus 1, this will be minus 3. And finally you're going to have negative 3 times negative 5. This one will give you positive 15. X raised to, again we minus 1 from this negative 3, it's going to be negative 3 minus negative 1 is negative 4. And finally, that is how your gradient function will look like. So let's move forward. Now also in our previous class, we said that differentiation again is simply getting the gradient function, and it is this function that will help us to get the gradient of a curve at a specific point, and that's what I want us to do. So we now example. So I've been told find the gradient of the given curves at the indicated points. So I'm having a y is equals to x squared minus 3x at point 2, negative 2. So we want to get what is the gradient of this function at this point. So we said you find the gradient function. The gradient function will be the one which will help you to get the gradient at this point. So you just come and say our dy dx will be, differentiate this one, 2 times 1 is 2, x raised to 1. If you minus 1, that will be 1. Then if you differentiate this one, this is like x raised to 1, so it is 1 times negative 3, this will be negative 3. Minus 1 will be x raised to 0, so that will be your gradient function. Then at, so this is a complete point with x coordinate and y coordinates available, so we only need the one of x because our gradient function, whatever is missing is x, so we need to know what is x, then we know what is dy dx. So we can say at x is equals to 2. Now if you substitute back in this function, we're going to say our dy dx will be 2 multiplied by 2 minus 3. So this will be 4 minus 3. So that will be 1. So our gradient at this specific point is 1. B, we're having y is equals to negative x raised to 2 at point 0, 0. Like that one. So again, we differentiate this one. This one will be dy dx is equals to 2 times negative 1 is negative 2 x raised to 1. So it remains like that, because if you minus 1 from 2, it will be x. That is our gradient function. Then at x is equals to 0, our dy dx will be negative 2, 0. So meaning our gradient will be 0 at that point. Then the last one we can do, we are told to find the gradient of this function x squared, x raised to 4 minus 3x squared plus 6x at 0.14. So again, what we do, we just differentiate our dy dx will be 4 multiplied by 1, so this will be 4 x raised to 3. By now I hope you know what we are doing. Then minus, this one will be 2 times 3, this will be 6x, we minus 1 from that power, then plus, this will be like 1 here again, 1 times 6 is 6, so you minus 1 and you remain with that as your gradient function. Then we say at x is equals to 1, this will be 4, you substitute the value of x in this function, that will be 1 cubed minus 6, 1 plus 6. So we're going to end up with 1 raised to 3 1 times 4, it is 4 minus 6 plus 6. So finally our answer is just 4. That is how we differentiate. Continue following us for more. Thank you.